actin, right? M stands for myosin. These are the two contractile proteins. This one's the thick one, this one's the thin one. So I got to draw this out. I'm in the top left corner. Here's the actin, here's the Z line. Now this is very simplified. It really is kind of that, the Z line is zigzagged, but I'm not making it that way, so I keep it the same as what your diagram looks like. I made this on a computer a long, long time ago, and it probably could be redone. So here's the thick filament. So I'm just going to point to A, this is M, this is actually called an M line, right there, that little mark. And, I'm going to only draw one cross bridge just to make this simple for us. But you saw there's a whole bunch of these things. So there's like a golf club like looking thing, and I didn't mean it to be touching. So there is a little gap there, but it's tiny. So it's not touching right now. So I'm going to give you a little, it's like a chemical formula that tells what's going on. I'm going to put here M asterisk, and when you put a dot there, it's like it's multiplied by, and it's going to be ADP plus P. Now, ADP plus P is adenosine phosphate plus phosphate. So let me just, don't write this in the middle. You know, if I have an ATP molecule, this thing could break down into, now let's do it. Let me just write it like this. It's an A with 3 phosphates attached to it. Doesn't that what the name implies? Adenosine, there's the A, and tri, what's that, the number of?
3.
3 phosphates. And I draw a squiggly line here to indicate it's a high energy bond. So if you break these bonds, they release a lot of energy. And that's what's powering the cross-bridge cycle. So if ATP breaks a phosphate off, what do you call it then, or how do I write it? I'm going to write it ADP plus P. Does that make sense? It broke, I broke one of those off, and that released energy. And so that's how our cells work, how the pumps work, and all of that. Someone hit that paper towel machine there, right back there. And I'll Thank you, Felix. I just got to have an eraser. When's the last time a teacher used the overhead projector?
Middle school.
Or have you ever used? This is like my favorite tool. I've taught for 25 years with these, and I can't give it up. I use them all the time, but I try to be technologically with it as well. But it has a good use. All right. So I just kind of explained what that represents. Now the energy from that broken bond went to myosin. That's why I put it with an asterisk. And we can write some of that stuff out. So it really is, that's kind of step 4, step 1. We're setting this thing up so that it can do a contraction cycle. So now I'm just drawing an arrow. We're going to draw what it looks like over here. Same thing. And you see this cross bridge, and there's just 2 dots there. That's just reference point. Whoops, now I'm supposed to have a touching darn it. So now it reaches up. Here it's not. I just made it too close. It reaches up. As soon as it does that, I'm going to draw a little formula. This just helps me describe what's going on. If there's a dot between A and M, it means they're touching. So I forgot to put it. Let's put this. Here's actin. It's just bothering me. So I'm just going to make it look a little more spaced out right there. Okay, it's not touching. So because it's not touching, I'm saying A plus M. Does that make sense? Now it is touching, so I'm saying it's A times M. Follow? So this myosin is all charged up. I didn't bring it, but it's kind of like a mousetrap. You know when you pull that spring back, you just loaded it with energy, right? Because you want that thing to whack a mouse right on the head. So you pull it back and you hold it there with the latch. Right now, this is like a loaded spring. It's a loaded mousetrap. And as soon as it touches actin, it's going to contract. And that's what we're going to see next. So same picture. But this time, if you look at what's going on here, I'm going to exaggerate a little, but here's our two dots. Look at the power stroke. The cross bridge moved. It was kind of straight up, now it folded over. That's the spring-loaded mechanism, and it's stuck to the actin. It literally pulled. Do you see the distance here between the Z line and the myosin? What is it like now? It's closer. We just ratcheted in the sarcomere, and now we're going to draw it A times M. Why am I leaving it just like that? There's no energy left in the myosin. It was just used up to power the cross bridge. And we're going to put over here this ADP plus P. Think of it as a half-used battery, and they're rechargeable. So how do I get ATP back from this? There's a chemical that's also stored in our body, and weightlifters will actually take it as a supplement. It's called creatine, but this is creatine phosphate. And when that molecule breaks off a phosphate, the energy of breaking that off is transferred to this, which recharges the ATP molecule. All right? So you need to understand that creatine phosphate recharges a half-used battery, which ADP plus P is. And now we've got a fully charged molecule back to where we started. But the reason why we have to have this, and I kind of got off, it should have been lower in a sense, but you see what I'm drawing. ATP is required Here I have a cross bridge stuck to actin, and it's dead. There's no energy, and it's stuck there. ATP breaks the link between these. So if I draw this final picture, what we've been drawing the whole time, it's still folded over, but now it's not attached. Here's just reference points, is all that is. Now I'm going to draw this picture as A plus M, and ATP is attached to the myosin. A whole brand new, fully charged energy molecule is attached to the myosin, and that brings us back. What's going to happen between this step and this step, which we're calling yes, that's what I want. I want this step to be called step 4, because step 4 is kind of resetting the end. Step 4 to here is resetting the whole thing. It's the last thing. And so we're going to call this then step 1, step 2, and coming in here, this is step 3. But what happens in step 4, bridging this picture to this picture, is ATP breaks off a phosphate, and where does that energy go? It charges up myosin, it sets the cross bridge back. See how it's bent here? It's like used up. Now it sets it back, it's unhooked, and as soon as calcium comes in and exposes the binding site here, if calcium comes in, you gotta have calcium, you gotta have ATP. This will reach up again and ratchet it in. And it's just super fast. I mean, it's happening, I don't know how many thousands of times per second, and there's bajillions of these cross bridges doing that. So, anyway, does it make sense to you? Yes, no, questions?
So, how do we get, okay, I understand that we get rid of one of the phosphates. How do we get ADP? Why does it ADP?
It's just the name, adenosine diphosphate.
Is it for the two phosphates,
So
right?
now this molecule looks like this. That's called ADP. That's a good question, because how many phosphates do you see? Two, so it's adenosine diphosphate. And you could go one step further, right? What if I broke this off and I had this, A, P, and then it would be plus P, plus P. That would be adenosine monophosphate,
Oh, okay.
plus a phosphate, plus a phosphate. So it's just the prefix for how many phosphates you see, okay? And ATP, of course, was the one we wrote. This is ATP, this is ADP, this is AMP.
Thank you.
Yeah, it's a good question. I'm going so fast, I'm not really hitting every detail, so you gotta tell me what you maybe don't follow. Anything else? So I'm gonna shut that off then and go back to the PowerPoint.